Welcome to Godot Essentials for 2D games. In this episode, we'll take a look at how to move our character in 4 and 8 directions. We'll also animate our hero for walking, running, and attacking. And as a little bonus at the end, we'll dive into some advanced animation tricks for more polished gameplay. So sit back, enjoy the video, and hey, thanks for liking, sharing, and subscribing. In this series, we won't waste time on fluff. We're packing as much knowledge as possible into short and snappy tutorials, so buckle up and let's dive right in. First, switch to the 2D view and create our main scene node, a character body 2D. Next, we add an animated sprite 2D to handle the visuals and a collision shape 2D so our character can interact with the world properly. Make sure both are children of the character body 2D. That's important for everything to move together. Let's save our newly created scene. And pro tip, keep your folder structure clean and logical. Trust me, once your project grows, you'll be thankful you took the time to stay organized. First, we'll create a dedicated folder for this scene. Then, let's set up another one for all our sprites and visuals. That's also the perfect place to keep your tile set graphics, by the way. Once that's done, you can open your file explorer and drop your sprite images directly into this folder. If you don't have any graphics yet, no worries. Check out the link in the video description. It'll take you to Game Endeavor's itch.io page, where he shares a bunch of his awesome artwork for free. Huge thanks to him for that. With our sprites now loaded into the project, it's time to bring our character to life. In the inspector, under the animation section of the animated sprite 2D, we create a new sprite frames resource. That's where we'll manage all our animations. Let's start with the idle front animation. We'll load our sprite sheet here, and then, very important, we define how the sheet is split, both horizontal and vertical. That way, Godot knows how to slice it up, and lets us select each frame in the correct order. Alright, we've got our little character on screen, but looking a bit blurry, isn't he? No worries, let's head over to the project settings. Under rendering, textures, turn off the filtering option. And boom, crisp pixel art, just the way it's meant to be. Now let's position our character right at the origin, aligning the center of the shadow to 0, 0. That'll make things easier later on. But we're not done yet. Our character still needs a collision shape 2D so it can interact with the world, like bumping into walls, or, angry mushrooms. For this character, I'm using a capsule shape 2D, but depending on your sprite, you might go with a rectangle or circle instead. Totally up to you. Now adjust the size of the shape so the collisions happen exactly where you want them to, not somewhere off in no man's land. Take your time here. It really helps with precise interactions later on. And that's it. Our character setup is complete. Let's hit save real quick and jump straight into scripting. Time to bring this little pixel hero to life. Before you start coding, make sure to save the script. Again, keep things tidy. I recommend creating a dedicated folder for your scripts. Staying organized now will save you a headache later. Trust me. We now have our script, and it's already linked to our player scene. You can always switch back and forth between the scene and the script, which is super helpful for making quick adjustments. Let's kick things off by defining our variables. At this point, we only need one, and that's speed. We'll set speed equals 50. This value depends heavily on the size of your game world and your character's scale. For our setup, 50 feels just right. Not too fast, not too slow. Next, we jump into the ready function. This is where we define what happens the moment the scene starts. Here, we'll start our character's animation right away. So if you've got an idle animation set up, this is where it begins to play. Now it's time to move on to the process function. This is where the action happens. This function runs every frame and executes whatever we put inside. It's perfect for things like movement, animation updates, or checking player input. So here, we'll call one of Godot's most important built-in movement functions, move and slide, This is your go-to method for smooth, frame-based movement in 2D. Right after that, we'll call a custom function of our own. Let's name it player movement. This is where we'll handle the input. But first, let's set up our own input actions. I prefer defining them myself instead of using Godot's defaults. It gives us more control and helps you understand how it all works. Let's start by naming our actions. I'll go with up and assign 2 keys to it. Then I'll do the same for down, left, right, sprint, and attack. Alright, the last key is set up, so let's jump straight into the movement function. Here we check if any of our movement keys are being pressed. If they are, we set the velocity to our speed value. Velocity is a built-in property that works with character, body 2D, and move and slide. Since we're starting with simple 4-direction movement, we'll use the X and Y axis. We'll do this for all 4 directions. Just make sure to carefully assign speed or 0 to the right axis, depending on the direction. Depending on your game design, sticking to just 4 directions might be totally fine. We'll get into diagonal movement later when we cover full 8-directional control. For example, the game I'm currently working on uses only 4 directions, and honestly, it works great. If you're curious to see what this little guy is capable of, check out my other playlist. There's a link up there in the corner. And that's pretty much it. Simple, right? Let's hit play and see what we've got. Nice! Our little guy is moving. Wait a minute. He's not stopping. Yeah, we forgot something kinda important. Our character just keeps on going like he's got somewhere urgent to be. Let's head back into the code and fix that real quick. What we need here is a state where the velocity gets reset back to 0. And that state, of course, is when no input keys are being pressed. Right now, we're using several if statements to check for input. It's a good idea to replace those ifs with else ifs. Now let's head back into the project settings and adjust the size of our game window a bit, just to make everything easier to see. We'll also scale up our character by a factor of 3 to make him stand out more. Alright, let's hit play and take a look at what we've got. The 4-direction movement works perfectly, smooth and responsive. With that done, let's move right into 8-direction movement. We can delete our old movement function, or, like I'm doing here, just comment it out in case you want to reference it later. Of course, we still need a function to handle the new movement. We can go ahead and reuse the old speed variable. No need to define a new one. Oh, and this little @export tag, it just means we can tweak the variable directly from the inspector over here. For our new variable though, we don't need that. We'll keep it simple and handle everything in code. This variable will store the player's input direction as a vector. To start, we'll set it to vector 2.0, which basically means no movement. Then we'll assign the movement inputs directly to this vector. And finally, we multiply the vector by our speed to get the actual movement. And that's it. Seriously. With a much simpler function, we now have clean 8-directional movement. Let's hit play and check it out. Smooth movement in all directions. Perfect. Next up, let's animate our little guy's movement. The process is the same whether you're using 4 or 8 directions for movement. First, we need to check which direction the character is facing. We do this by checking which input is currently being pressed, and then we assign a new variable to represent that movement direction. Just a quick heads up, don't give your variable the same name as your function, that'll mess things up. So we start by setting the variable to an empty string and then assign the proper value depending on the input, like up, down, left, or right. Now, in my example here, the character animations only include 4 directions, so diagonal movement won't look 100% accurate. But hey, it still works and looks pretty good. Now it's time for the final function, the animation function. This is where we bring our character to life by checking the movement direction we set earlier and playing the right animation based on it. Let's start with walking to the left. You already know how to assign sprite frames, so let's quickly take care of that as well. We'll name this animation walk side, since we're going to use the same animation for both left and right movement. To handle the difference, we'll simply flip the sprite horizontally using flip H in the script, easy and efficient. This way we can keep our sprite sheet compact and still get smooth directional animations. Once that's in place, we'll move on to the other directions, one step at a time. Now we're going to create all the animations we need. That means idle in all directions, walk in all directions, and attack in all directions. To keep things moving, I'll speed up the video a bit while I go through the setup. Let's go ahead and finalize the function to include all 4 directions and assign the correct animations for each. We're using else if statements again to make sure only one animation state gets triggered at a time. And don't forget to actually call the animation function inside _process. Yeah, I forget this way too often and end up wasting time debugging something that's not even broken. Also, I just noticed a little mistake. The flip H command wasn't set correctly. I need to set it to true when walking left and back to false when walking right. Looking good so far. The movements are animated, diagonal directions work smoothly, and we're ready to move on to the next steps. We haven't created our idle animations yet, and while we're at it, let's also add a sprint mode. You probably noticed how our little guy does a bit of a moonwalk when he stops. Let's fix that. For sprinting, we'll create a multiplier that boosts the movement speed when the sprint key is held down. Inside the player movement function, we'll check if the sprint key is pressed, and if it is, we'll increase the movement speed using that multiplier. Now let's handle idle animations in the player animation function. We'll simply check if the player is moving, and if not, we'll play the corresponding idle animation instead. Now let's go ahead and copy the whole animation block and tweak it for the idle animations. Let's see how things look now. Sprinting works and the idle animations play correctly in all directions. Perfect. So next up, the attack animation. We'll set up a new function for this and it's going to be very similar to what we've already done. This time we'll use the isActionJustPressed function. That way the attack only triggers when the button is pressed, not when it's being held down. But for that, we'll also need something to reset the attack after it's finished. First, we'll stop the player's movement while they're attacking. We'll also use a variable to check if an attack is currently in progress. And just like before, we'll play the correct attack animation based on the direction the player is facing. As mentioned earlier, we now need a timer to reset the attack. Looking at our sprite frames, we can see we have 4 frames for the attack animation. So if we set the playback speed to 4 frames per second, the entire animation will take exactly 1 second to complete, which makes things really easy to manage. Now that we know the attack takes 1 second, we can also set our timer's wait time to 1 second. We'll start the timer right when the attack begins and then connect its timeout signal. This lets us reset the attack variable when the time is up. Without this setup, pressing the attack key repeatedly would just keep resetting the animation, and we definitely don't want that. And lastly, we need to make sure that no other movement or animation runs during the attack. Otherwise, the attack could get interrupted or overridden by something else. Before we jump into the bonus content I promised, let's take a moment to check out the full animation in action. Here it is, attacking, walking, sprinting, all working smoothly. Of course, there's still room for improvement and fine-tuning as we continue developing our game. For example, the animation speed doesn't change when sprinting, but we can fix that easily in the code and it'll instantly make your animations feel more dynamic. You can even apply the same principle to the attack animation. Let's say your character increases their attack speed later in the game. You'd want the attack animation to speed up as well. So, let's take a look at how to make those adjustments. With the following command, we can directly access the animation speed of any given animation. Let's start by applying this to sprinting. We'll slightly increase the animation speed when the player is walking and sprinting, so the visuals match the faster movement. We'll keep it simple and define 2 different speeds, one for walking and one for sprinting, and we'll set them right inside the player movement function. With this command, we're directly adjusting the frame rate of the animation. So we'll need to set the value in FPS. Now I'll increase the FPS for walking and also for sprinting, scaling it proportionally to the character's movement speed. And look at our little guy now. That sprint animation looks so much better. Watch those tiny legs go as he dashes across the screen. Absolutely adorable. Alright, let's wrap up the movement animations by applying the changes to all directions, and then jump right into the fun part, speeding up our attack animation. We'll introduce a new variable for attack speed and set it to match the default frame rate of the attack animation. In our case 4 FPS to start. Just for demonstration, we'll increase this speed a little after every attack, and we'll make sure to adjust both the animation speed and the timer accordingly. That way, the whole attack sequence, from animation to reset, keeps up with the faster pace. Here we make sure that the attack speed increases with every strike. Once the attack animation finishes, we update its playback speed by setting it to our attack speed variable. To adjust the timer's wait time, we first need to stop it, and then use this line to set the new time dynamically. To better track what's happening during testing, we'll print both the updated attack speed and the timer wait time in the console. Let's run the test and see how this little optimization looks in action. Okay, it's not working as expected. The attack speed increases, but as we can see, the wait time doesn't update correctly. Debugging time. Everything looks fine at first glance. Wait a second. Wait time needs to be a float. Small mistake, big impact. This is coding, folks. Quick fix, and let's test it again. Boom! Now the animation speeds up with every hit, and we've got ourselves a little Ronin on screen. That looks great. With this setup, you can make sure your animations scale properly as your character levels up, whether it's attack speed, spell casting, or any other action. If you're wondering what to do with all the new skills you've picked up, why not check out my RPG creation series? It's packed with ideas on how to bring your character to life in a full game. You'll find the link popping up right now in the corner. Go take a look. In the next episode, I'll show you how to use Godot to create a functional and beautiful world on a large scale, with proper tile maps, tile sets, Y sorting, and collisions. And if you're excited to see the upcoming episodes, please leave a like and subscribe to the channel. It really helps me a lot and supports this series. Thanks for watching, and have fun coding. See you next time.